Hi, I'm Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, my lesson is on some problems on line integrals. In the previous session, we have seen what is the line integral and what is the circulation and what is the work done by force vector F bar and how to find out the work done by the force vector and how to find the circulation V bar, where V bar is the velocity vector of the fluid. Normally, how to find the line integral, that already we have seen. And in this session, we want to do some more problems on line integrals. So, the first problem is compute the line integral y square dx minus x square dy round the triangle whose vertices are 1, 0, 0, 1 and minus 1, 0. So here I would like to solve the problem. So already given what is the line integral means. Line integral is solution f bar dot dr bar over the curve C. Here C is the closed curve because C is the triangle with vertices. One is 1, 0. Suppose if you take the coordinate system, this is x, y. So where it is 1, 0. So on x-axis it is 1, 0 and 0, 1 will be on y-axis and minus 1, 0 that will be also on x-axis on the negative side. And these are the vertices. Let this is A, this is B, this is C, and the triangle formed is like this. So we have to find the line integral along this triangle. So already given that, compute the line integral. Already f bar dot dr bar already calculated and the value is identified as y square dx minus x square dy. So now our aim is to find the line integral along AB, then along BC and along CE. So the complete round will be the total line integral value. So already given integral f bar dot dr bar around the curve C is equal to integral y square dx minus x square dy. Already given that this is. Now case 1. So what is case 1? Along the arc AB or along the line AB. So I am going to evaluate the line integral along AB. This is nothing but along AB plus along BC line integral. Along AB plus along BC plus along CA. So the complete integral to calculate, we need to find the line integrals along AB, along BC and along CA. So first case 1 is, I want to find the line integral along the line AB. So along the line AB, line integral. So here, what are the things we can observe that? Here y is constant, y is 0 because x-axis, here y is equal to 0. This is the line AB. AB means it is on x-axis. So the equation of x-axis is y is equal to 0. Or you can observe that here the y coordinate, here also 0, here also 0. That means y 0. Y 0 means what? dy 0. dy 0. But x is a variable. X here start with minus 1 and it is 0 and then it reaches to 1. That means what? X is a variable factor. It varies from minus 1 to plus 1. So I am studying the line AB. Along the line AB, y constant, y is 0 always. But x is a variable. It varies from minus 1 to 1. Therefore, what is the line integral? Integral along AB, the function what is given? Y square dx minus x square dy. The function is same. Is equal to. So y0. Y0 means first term is 0. Y0 means first term 0. So whatever may be the dx is as it is 0 dx, that is 0. minus x square dy. Dy also 0. Y 0, dy 0. That means 0 minus 0. That is equal to integral 0. That is 0. It is case 1. The case 1 line integral evaluation value is equal to 0. Similarly, we write the line integral along BC. Along BC means this is. So what is this line equation? X-intercept 1 and y-intercept also 1. So the equation intercept form is x plus y is equal to 1. What is this line? Y is equal to 0. This is the line. This line is x-intercept 1, y-intercept also 1. So we know that the line intercept form is x by a plus y by b is equal to 1. Here a1 and b1. So x by 1 plus y by 1 is equal to 1, or x plus y is equal to 1. So that is the equation of the line joining of the 2 points 0, 1 and 1, 0. Similarly, what is this line? So here x-intercept is minus 1 and y-intercept is plus 1 is equal to 1. X-intercept minus 1, y-intercept 1. So what is the line equation? Y minus x is equal to 1. Am I right? This line is y minus x is equal to 1. This line is y minus x is equal to 1. This line is x plus y is equal to 1. This line is y is equal to 0. Now I would like to find the line integral along BC. Along BC means we have to find the line integral along the line x plus y is equal to 1. So here the values x varies from 1 to 0 and y varies from 0 to 1. Y varies from 0 to 1. So x plus y value is 1 minus x. Now I'd like to calculate the case 2. What is case 2? Case 2 is along the curve or along the line BC. So here what is the line equation here? X plus y is equal to 1 or y is equal to 1 minus x. So on differentiating dy is equal to minus dx. X plus y is equal to 1 is the line equation, or y you can write 1 minus x. On differentiating both sides, dy is equal to minus dx. So if you can replace dy for minus dx and x varies, you can consider either x variable factor or y variable factor. If x is a variable factor, it varies from 1 to 0. X varies from 1 to 0. I will write it. X varies from 1 to 0. I hope this is clear. Along the line BC. So BC means this is the line. This line is BC and this is the point 1, 0 and this is 0, 1. The line equation is x plus y is equal to 1. Along the line means x plus y is equal to 1 is the line equation, or y is equal to 1 minus x, or dy value minus dx. And here x, if you want to take, it varies from 1 to 0. Therefore, integral along BC, am I right? F bar dot dr bar is equal to integral along BC. What is the function? Already given in the itself, y square dx. Y square dx minus x square dy. So along BC means what? Y value, I have to take 1 minus x. Y value 1 minus x whole square dx as it is, minus x square as it is, and dy is equal to minus dx. And x varies from 1 to 0. I am transforming all the functions in the terms of x. Y can be replaced by 1 minus x. And dx is as it is dx minus x square as it is. And dy is replaced by minus dx. Now the entire term is a function of, so this is 1 to 0 and 1 minus x whole square expansion 1 plus x square minus 2x, and this will be plus x square minus of minus plus x square of dx. I hope this is clear. 1 plus x square minus 2x. This is minus of minus plus x square of dx. So that is integral 1 to 0, and x square means x square plus x square 2x square minus 2x plus 1 of dx. So what is the integration? 2 into x square integration x cube by 3 minus 2 into x integration x square by 2 plus integral 1 into dx. That means integral dx is x between 1 and 0. So on substituting the limits, upper limit, all are zeros, minus lower limit, 2 by 3 minus 1, on writing 2 to cancel, 1 square, that is 1 plus 1. Upper limit, entire limit is 0, 0 minus 0 plus 0, 0, and lower limit minus of this one. So here minus 1 plus 1 also gets cancelled. The value is equal to minus 2 by 3. This is the line integral along BC. The line integral along BC. Similarly, you can find the line integral along CA also. So what is the last line? We have to find the line integral along CA. So that can be done by, I will see here. Now case 2, not case 2, case 3. So what is the last one? Along the line CA. So this is, what is CA line? See, this is A, and C is 0, 1, and this is minus 1, 0. So what is the line? Already I told you that x by x-axis minus 1. And this means y minus x is equal to 1. This is the line equation. Y minus x is equal to 1. X-intercept minus 1. Y-intercept 1 is equal to 1. Or y minus x is equal to 1. So here, what is the line? Y minus x is equal to 1. Or dy is equal to, first you write y is equal to 1 plus x. So dy is equal to dx. Am I right? Dy, on differentiating with respect to, suppose on taking differentiation, dy is equal to 1 derivative of 1 constant 0 plus dA is equal to dx. Dy is equal to dx. And suppose if you consider x limit, x varies from 0 to minus 1. Here, and the limit x varies from, you can take x limit or y limit. If you transform the entire function in the terms of x, we have to go for x limit. If the function is transformed to y limit, then you have to substitute the y limit. X varies from the limit 0 to minus 1. So I am finding the line integral along AB, along BC, along C. That will be the total around the line integral. So here, therefore, integral f bar dot dr bar along CA is equal to integral x varies from 0 to minus 1. The function, what is the function? Already we have used the function y square dx. Y square dx minus x square dy is equal to, this is x0 to minus 1. So what do you have to substitute? Y for 1 plus x. Y for, I have to substitute 1 plus x whole square of dx minus x square as it is, and dy is equal to dx. So on substituting these values, 0 to minus 1, here expression on expanding 1 plus x whole square, 1 plus x square plus 2x and minus x square of dx. 1 plus x square plus 2x minus x square. These two gets cancelled and the value is integral 0 to minus 1, 1 plus 2x of dx. So what is the integration? This is first term x, integral dx x, second term 2x square by 2, and the limits are 0 and minus 1. So 2 to cancel. So on substituting the upper limit, here I will write x, instead of x it is minus 1. And substituting the upper limit x for minus 1 plus lower limit minus 1 whole square, that is plus 1. Minus 1 whole square plus 1, lower limit both are 0. That is minus 1 plus 1, this is equal to 0. This is equation number 3. Therefore, what is the conclusion? We have to find the complete line integral along the closure curve C. Therefore, integral f bar dot dr bar around the closure curve C is equal to integral along AB, then along BC plus along CA. So what is along AB? So I will see what is along AB. First one, 0. 0 plus of minus 2 by 3. Second minus 2 by 3. And last one also 0. So what is the line integral value? that is minus 2 by 3 is the required solution. So I'm calculating it is over the curve C. This is called entire curve. This is C is the vertex. So just remember that AB and BC and CA. The complete integral will come as minus 2 by 3. So in this way we can find the line integral along the triangle. That means along the rounded curve, whether it is a triangle or rectangle or square, you have to find like this, right? Next, I'm going to solve another problem based on line integral only. Compute the line integral f bar dot dr bar, where f bar is x minus 3y into I bar plus y minus 2x into j bar around the closed curve. In the xy plane, x is equal to 2 cos t, y is equal to 3 sin t, from t is equal to 0 to t is equal to 2 pi. So already f bar is given, it is a vector. As per the given problem, I am telling that here f bar is defined in the xy plane. So f bar is defined in xy plane. That means z0, dz0. There is no term of z here. But x is given as in the terms of the parametric form. Given that x is equal to 2 cos t and y is equal to 3 sin t. And here t limit also given, that is 0 to 2 pi. So this is the information given. The plane, the curve is a parametric curve. X is equal to 2 cos t and y is equal to 3 sin t. Okay. So now what do you have to find? Integral f bar dot dr bar as usual. So first write integral f bar dot dr bar. So integral over the curve CF, what is f bar? X minus 3y into I bar plus y minus 2x into j bar of dot product with dxi bar plus dyj bar. Dxi bar plus dyj bar. So z term is 0 because the curve is defined in xy plane only. So which is equal to, what is the value? X minus 3y into dx plus y minus 2x into dy. Y minus 2x into dy. This is integral f bar dot dr bar. Remaining all terms 0. So this into dx plus this into dy. So this we have to evaluate. So this is to be evaluated along the closed curve C. So but here is given x is 2 cos t, y is 3 sin t, t is 0 to 2 pi. Entire things are given. Just we want to substitute in this. So before that I will use x is equal to 2 cos t. Then what will be dx? This is minus 2 sin t dt. I would like to change all the function in the terms of t. So this is can be done by substituting x is equal to 2 cos t. So the dx is equal to minus 2 sin t dt. Similarly, y is to replace it by y is equal to 3 sin t. Then what is a dy? That is 3 into sin t will be cos t of dt. So now see this integral. Therefore, integral f bar dot dr bar is equal to integral x minus 3y. X means what? 2 cos t minus 3 into y. Y means again multiply with the 3. That will be 9 sin t. So I'll come here 9. This is 9 sin t. What is dx? Dx is minus 2 sin t dt. That is the first term. I am replacing x for 2 cos t and y for 3 sin t, dx for minus 2 sin t dt and dy for 3 cos t dt. So I am changing the total function in the terms of t plus y minus 2x. What is y? Y is 3 sin t minus 2 into x. That means 4 cos t of dy. Dy means 3 cos t dt. So this is the integral f bar dot dr bar along the curve C. This we have to simplify. And t limits also given. T is equal to 0 to 2 pi. So that I can substitute. So now on simplifying, I will do and write. This is integral f bar dot dr bar along the curve C is integral along the curve C. So I will write step by step. So 2 cos t into minus 2 sin t. First term, 2 cos t into minus 2 sin t. So minus 4 sin t cos t. I will write minus 4 sin t cos t. Next, second term, minus minus plus, 9 2s are 18 sin square t. 18 plus 18 sin square t dt. So dt I will write for last. Next, 3 sin t into 3 cos t. That is 9 sin t cos t plus 9 sin t cos t. And what is the last term? So this is minus 12 cos square t. Minus 12 cos square t dt. So that is on simplifying. So this will get 18 sin square t, that is one term, minus 12 cos square t is one term, 9 sin t cos t minus 4 sin t cos t. That will be the 5 sin t cos t of dt. So this is equal to, so I can write, what is the formula? We have cos square t minus sin square t is equal to cos 2t. Similarly, 1 minus 2 sin square t is equal to cos 2t. 2 cos square t minus 1 is also cos 2t. So you can substitute, this is sin square t. Sin square t means 1 plus cos 2t by 2. We can write sin square t can be written as 1 plus 18 into 1 plus cos 2t by 2. So that is the first value. Minus 12 into cos square t. Cos square t, how I can write it, is equal to cos 2t. Cos square t means 1 plus cos 2t by 2. 1 plus. This is 1 minus because sin square. You have to write it as 1 minus. 1 minus 2 sin square. 2 sin square t I am writing like this. 1 minus cos 2 by 2. 1 plus cos 2t by 2. Right. Plus, this is 5 by 2 into sin 2t of dt. So multiplying and dividing with 2, 2 sin t cos t, that is 5 by 2 sin 2t. So this is equal to, on simplifying, 2 into 18, 9. So integral 9 into 1 minus cos 2t, that is one term. 2 6 are 18, that is minus 6 into 1 plus cos 2t plus 5 by 2 into sin 2t of dt. So what is the limit? T is equal to 0 to 2 pi. T is equal to 0 to 2 pi. Now I can simplify integral 0 to 2 pi. What is the constant term? 9 minus 6, 3. 3 the constant term. Minus 9 cos 2t is one term. Minus 6 cos 2t is one term. Plus 5 by 2 sin 2t of dt. So this is second term. Or we can write minus 9 minus 6. That is minus 15 cos 2t. So I will write in the next slide as integral 0 to 2 pi. So what is the constant? 3. What is the constant? 3. 3 minus. So what is the value? Cos 2t factor minus 15. Minus 15 cos 2t and plus 5 by 2 sin 2t. Plus 5 by 2 sin 2t of dt. So the function all getting to transformed into t terms, and the limits also according to t limits it is 0 to 2 pi. Now on integrating first term 3t. So 3 into dt. So 3t minus 15 cos 2t integration sin 2t by 2. Cos 2t integration sin 2t by 2 plus 5 by 2 into sin 2t integration minus cos 2t by 2. The limits are 0 to 2 pi. So on substituting the upper limit 3 into t place 2 pi minus 15 by 2 sin, this is 4 pi. On replacing t for 2 pi sin 4 pi minus 5 by 4 into cos 4 pi. And what about lower limits? Minus 0 plus t0 means 3 into 0, 0, plus 15 by 2 sine 0, 0, plus 5 by 4 into cos 0. So these are the limits for integration 0 to 2 pi. First you have to substitute upper limit. The three terms we will get minus lower limits on substituting these. So 6 pi, this is one value. Sine 4 pi, 0. So minus 5 by 4 into cos 4 pi, that is equal to 1. It is nothing but cos 0. Plus 5 by 4 into cos 0 also 1. So these two are gets cancelled. So the required solution is 6 pi. That is the required answer. The line integral along the curve C, f bar dot dr bar is equal to 6 pi is the required solution. So this is the parametric curve. So in the previous examples we have seen the x function, x term and y term. Those are called the Cartesian curves. But here this is the function x is given in terms of t and y also given in terms of t. So we have changed all the terms in the terms of t and we have t limit. So on substituting and finding, we will get this solution. And I will do another problem also. So this is a similar problem. We can do as homework. We can make it as a practice problem. F bar is equal to x by I bar minus z into z bar plus x square into k bar. And C is the curve. X is equal to t square, y is equal to 2tz. But it is defined in the xyz system. Xyz means like this. X-axis, y-axis and z-axis. So it is defined in three-dimensional space. And f bar given. And f bar dot dr bar, you can find f bar dot dr bar, what you will get? F bar dot dr bar is equal to, so I'm doing operation xy dx, that is one term, minus z into dy plus x square into dz. That is the term along the curve C. So given the curve is in parametric form, x is replaced by t square, y has to replace 2t and z has to replace tq. Then you can find dx, dy, dz and substitute all the values in this dx, dy, dz. And all will come into single variable. So I will do this integral. X means t square, y means 2t. And what is dx? Dx means 2t dt. Dx is equal to 2t dt. Am I right? So what is dt? This is dy is 2 dt. dz is equal to 3t square dt. So I'm substituting separately x, y and z and dx, dy, dz minus, what is this? Z into, so what is z? Z means it is t cube. Z means t cube and dy. Dy is equal to 2 dt. That is another term. Plus x square, that is t power 4. X is t square. X square means t power 4. And dz, that is 3t square into dt. So t limit 0 to 1. So substitute, this is 0 to 1, 2 into 2, 4 t power 4. That is first term. Minus 2t cube, that is one term. Plus 3t power 6 of dt. 3t power 6 of dt. So on integrating 4t power 5 by 5 minus 2t power 4 by 4 plus 3t power 7 by 7 between 0 and 1. So on substituting the limits 4 by 5 minus 2 by 4, 2 by 4 right, plus 3 by 7. 4 into t power 5 by 5, 2 integration t power 4 by 4, 3 t power 7 by 7. So I'm doing integration. So what is the LCM? 5 4s are 20, 140. Am I right? So 5 2s, 5 8s, 5 28s, 28 4s, 112. Am I right? 5 into 28. 5 20s are 100, 5 8s are 40, 140. 28 into 4. 4 8s are 32, 4 2s are 8 plus 3, 112 minus 4 into 4, 4 3s are 12, 4 5s. 4 35s are 140 and 35 2s are 70, second term. 7 20s to 23s are 60. So that is 112 minus 10 by 140. So what is the value? 102 by 140. So this is the required solution. You can cancel it also. So this will be the required solution of the given problem. So just go through that xy minus z into dy plus, because what is dr bar? What is dr bar means? Dr bar, please remember, dxi bar plus dyj bar plus dzk bar is the dr bar, and making dot product f bar with dr bar, we'll get xy dx minus z into dy plus x square into dz. So that is the third problem that can be solved easily. So this is also the problem of finding line integral f bar dot dr bar along the square. So here there are given f bar is function and f bar dot dr bar, and given square in xy plane, that means z0. So I will solve this last problem or day before. F bar is equal to x square plus xy into I bar plus x square plus y square into j bar. Then what is f bar dot dr bar? This is x square plus xy I bar plus x square plus y square j bar, dot product with dx I bar plus dy j bar. What is r bar? R bar is xi bar plus yj bar plus zk bar. Then dr bar is dxi bar plus dyj bar plus dzk bar. So I'm doing this x square plus xy dx plus x square plus y square into dy. There is no z term because the curve is defined in xy plane. So there is no z term, only x term, xi bar plus yj bar and dxi bar plus dyj bar. The product will be like this. This is f bar dot dr bar. Now we have to evaluate this line integral along the lines square. Square is x is equal to 1 minus 1. This is minus 1 0 and this is x is equal to 1 comma 0. Am I right? Minus 1 to 0, minus 1 to 1 comma 0 to 1 comma 0. That is one line. X is equal to 1 line. X is, oh, right. There is no line x is equal, y is equal to 0 line. Here x is equal to plus 1. Y is, here the lines are x is equal to 1 minus 1. Y is equal to 1 and minus 1. So between these one square is there. What is x is equal to 1 line? So I will show here. I will discard this. This is x-axis, this is y-axis, and x is equal to 1 line. This is x is equal to 1. This is the line x is equal to 1, passing through 1 comma 0. And x is equal to minus 1. So on the same distance, you will have the line x is equal to minus 1. And y is equal to 1. This is the line y is equal to 1. Y is equal to 1. And y is equal to minus 1. Y is equal to minus 1. So treat it as a straight line. So these are the 4 lines. x1, x minus 1. Y is equal to 1 and y is equal to minus 1. These are the 4 boundaries of this square. So we have to consider this is 0 comma 0. Then it is 1 comma 0 and this point is 1 comma 1. So the vertex C is 1 comma 1. And what is this vertex? B is x1 y minus 1. x1 y minus 1. So this is the point. And this is, what is the A value? This is A value. Minus 1 comma minus 1. X minus 1. And y also negative side minus 1. And what this is a D value? This is x minus 1. Sorry, x minus, not x minus 1. This is x is D minus 1 comma 1 by 1. So the vertices are A minus 1 comma minus 1, B is 1 comma minus 1, x1 y minus 1, and C is 1 comma 1, and D is minus 1 comma 1. So x minus 1, this is the point, and y is equal to 1. So the point is minus 1 comma 1. So we have to find the line integral along this square. So but clearly the length is 2. This is minus 1 to 0, 0 to 1, 2 units. This is also 2 units, so it is a square. So how to find? So you can treat this as a box square. So first find along AB, then along BC, along CD, and along DA. That will be the total line integral along the closed curve. See, so now what is along B, along AB? So first I will solve here. First one, along AB. Along AB. What is along AB? What is the equation of AB? AB equation is y is equal to minus 1. Y is equal to minus 1. Then what is the dy? Dy is 0. The derivative of minus 1, constant, will be 0. But here x is a variable, y is minus 1 fixed. You can observe that here also. Y is minus 1. Throughout this y value minus 1. But x is a variable factor. X varies from minus 1 to 0. X varies from minus 1 to, sorry, not 0, this is 1. Minus 1 to 1. Minus 1 to 1. Therefore, integral f bar dot dr bar along the curve C is integral f bar dot dr bar along AB plus along BC plus along CD plus along DA. That will be the total line. This is capital C. So always you write f bar dot dr bar, f bar dot dr bar, and f bar dot dr bar. So along AB, along BC, along CD, and along DA. So what is the case 1? So case 1 is integral f bar dot dr bar along AB. F bar dot dr bar along AB. So what is along AB? Y is equal to minus 1 and dy is 0. But x is a variable factor. X varies from minus 1 to plus 1. So what is f bar dot dr bar? See the function x square plus xy dx, x square plus xy of dx plus, so what is the second term? X square plus y square. X square plus y square of dy. So here I am putting y for minus 1. X square, y, instead of y I am putting minus 1. So minus x dx as it is plus dy 0. That means entire second term always 0. So 0. So the limits here is x varies from minus 1 to plus 1. That is integral minus 1 to 1 x square dx minus x dx. So what is the value? X square dx, x cube by 3 minus x integration, x square by 2. The limits are minus 1 to plus 1. So substituting the limit 1 by 3 minus 1 by 2. I'm putting x for 1 by 1. And here also x for 1 by 3 minus 1 by 2. And lower limit minus of minus 1 whole cube. That is minus 1 by 3. And here minus of minus plus 1 by 2. So this value, these two gets cancelled. So 1 by 3 minus 1 by 2. That is upper limit. Lower limit minus of minus 1 whole cube 3. That means minus of minus 1 by 3. And this is x square by 2. So plus 1 by 2. So these two gets cancelled, which is 2 by 3. So 1 by 3 plus 1 by 3, that is equal to 2 by 3. That is the first line integral value along AB. So similarly, you calculate along BC, along CD, along DA. So then the total integral value is equal to the required line integral along the closed curve C. Now I want to calculate along BC. Now I would like to calculate along, so case 2, along BC. So here I will draw the rectangle, square. This is x-axis, this is y-axis. This is x is equal to 1, this is x is equal to minus 1. This is y is equal to plus 1, y is equal to minus 1. So A, B, C, D. So now I am going to calculate along BC. Along BC, what is the equation? This is 1 comma x1 y minus 1. Here x1 y1, both are same. So here x is equal to 1 is the line, equation of the line. Equation of BC is x is equal to 1. So what is dx value? 0. But y is a variable factor. Y varies from minus 1 to plus 1. Y varies from minus 1 to plus 1. But x is fixed. Because the point is moving along the line x is equal to 1. X is equal to 1 is fixed. but y is varying, right? Varies from -1 to +1. Therefore, integral f bar dot dr bar along BC. That is integral. What is f bar dot dr bar? So that I will show. X square plus xy dx, x square plus xy dx plus x square plus y square dy. X square plus y square of dy. And here dx 0, that means entire first term everything 0. Second term x place low, I'm writing 1 square 1 plus y square as it is. So or you can write y is equal to, what is this equation? What is this equation? Y is equal to -1. So I can write it is, I'll write it as 1 plus y is equal to -1 whole square, because this line is y is equal to -1, and dy right as it is. That is equal to integral 2 dy between the limits -1 to +1. So all the function changed in the terms of y, and you'll get the values 2 into y between -1 and +1. So upper limit 2, 1 minus of -1. That is 2 plus 2. This is 2 into 2. 1 plus 8. That is equal to 4. This is the required line integral along BC. Similarly, we calculate along CD and along DA and find the total integral along the curve C is equal to along AB plus along BC plus along CD plus along DA. So that is given as a practice for the students. Along BC already I have done. Along CA, what is the equation? Y is equal to 1. Along CA, y is equal to 1. So I will tell just the points. Along CD, along CD, the equation of this line is y is equal to 1. So dy is equal to 0. Y is equal to 1 or x is equal to 1? Y is equal to 1. This is x-axis equation, y 0. This is y minus 1. This is y is equal to 1. So y1 means dy 0, but x is a variable factor, which varies from, x is a variable factor from 1 to -1. X varies from 1 to -1. So the entire function change into x terms and solve the given problem. So that will give the total line integral along the curve. So with these few problems solving, I conclude my lecture. Thank you for listening. In the next video, I will do the surface integral. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.